Let's continue reading, ladies and gentlemen. The causes of heat flow. There's going to be three focuses that you guys need to understand and the three vocabulary words. And the vocabulary words that we are going to define today begin with conduction, convection, and radiation. We've talked a little bit about this already, but we're going to continue talking a little bit more. We're going to define it clearly down here, so I want you guys to go ahead and write the word conduction. And as a class, we are going to create a friendly definition that we can come up with. Because when you guys make your thermoses in the next 2 weeks, it's going to be crucial that you guys are able to reflect. And I believe our last week of science class, as a class together, will be next Thursday. However, your assignment will still be extended to work on at home with your thermos the week after that. And then I'll have everything ready for report cards after we do that. But the nice thing is now with you guys joining Edmodo and joining our class, you guys will be able to communicate with me online, okay? Through your phones or through your computer. All right, conduction. Let's go ahead and begin our close read. And the purpose of this is to find textual evidence of what conduction is. We need to define the word conduction, find a good example and definition, and come up with a new friendly term that we can communicate as a class, okay? All right, I need you guys to go ahead and follow along. As a matter of fact, I want everyone reading out loud with me on the count of 3. Ready? 1, 2, 3. Conduction is the flow of heat from a high temperature source to a low temperature source through adjacent particles interacting with one another. Pause right there. All right. Did we find a definition already?
Yes.
Did it tell us what it does? Let me go ahead and read this a little bit more. Conduction is a flow of heat from high temperature source to a low temperature source, adjacent particles interacting with one another. Okay, let's stop right there. As you can see, I want you to see if you can line up these arrows. And I want you guys to notice a few things on this observation with this video right here. I'm sorry, with the drawing. You guys see the arrows. You have the arrows in the middle pointing up and the arrows on the corner going where?
Down.
Down. It's almost like, think about it. What it is that the heat is causing like a fountain. Have you guys ever seen a fountain like throw out water before?
Yeah.
So think about it. That's a physical representation of what heat is doing to water when it's being boiled.
Oh.
It's like a fountain and it's going up. All right. So what we need to do is define conduction. By looking at the photo and looking at what we've read already, heat from a high temperature source to a low temperature source. Particles interacting with one another. That's extreme scientific vocabulary and definition. But for you guys, I want you guys to be able to come up with an example or a different way of saying that. So I'm going to give you guys around 2 minutes to come up with a definition of conduction, starting when Siri tells us to go. Hey Siri, please set a timer for 2 minutes.
Okay, 2 minutes and counting.
All right, let's go ahead and come up with the definition with your table. I'll choose people randomly through Class Dojo to share what you guys came up with. All right, make sure you guys are ready. All right, let's go. All right. What are you guys thinking? As you look at that and look at the picture, and I would suggest this. Let's describe what's happening in the picture. Okay, it's boiling, and what else? What are the arrows doing?
It's boiling. It's going like in circles.
It's what?
They're going in circles and then going up
So the particles in the water are going in.
circles.
So what if we were to use that as a definition? Kind of like, what if we were to put
Particles.
when particles in the water, what's happening to the water?
It's going in circles.
But what kind of temperature is the water? Yeah. When the particles in the in the water are hot.
The particles go up.
They move. Well, what would you say? You said something earlier. They move in what?
And move in circles.
And for the particles, if you want to get really scientific, you can put H2O. That's actually pretty good. Do you guys see what we did? Did we have to really look at the definition and break those words apart, or can we look at the picture and kind of like...
We could look at the picture and try to see where it is.
Yeah. Do you guys see why it's important to draw models when it comes to science?
It's just describing the concept.
Right. And we understand it. So next time is awesome. You guys are grabbing and learning immediately that when I put my hand up, you guys put your hand up as well. Good. Okay. Let's go ahead and see what some people came up with. Troy, here's your chance to redeem yourself and get positive Class Dojo points. And I'm going to put, already give you that. So what, oh, not, well, whatever.
Source, no particles interacting with one another.
Dude, good job. Give a round of applause. That was really, really good. So when the particles are interacting with one another, okay? I want someone from my table to go ahead and come up with the definition that we came up with and tell them how we came up with our definition. Go ahead.
When particles in the water are hot, they move in circles.
So when particles in the water are hot, they move in circles. Does that seem kind of friendly to you guys? Does that seem something you guys could explain? Yeah? Yes. Yes, sir. Go ahead.
Conduction is the flow of heat from high and low temperature through particles coming together.
Okay, that works too. That's a very elaborate term, which actually is totally cool if you keep it that way. All right.
See how we got ours?
Oh yeah, we forgot to tell it. Christopher, go ahead and say how we got ours. And by the way, I like your name.
We were describing the picture.
So what was happening in the picture, Christopher?
We saw the arrows going in circles.
What was going in circles?
The particles.
Okay, the arrows represent where the particles are at?
Yeah.
All right, so that is convection. That is what's happening inside. So when you guys get your thermoses next week and you guys start making that, are you guys going to notice that, look where the arrows are moving. Heat is moving where? Up. But heat can also move, but as it moves down, it's still moving like a circle, right? So here's the thing. When you make your thermoses, do you have to find a way to trap the heat?
Yes.
Is that what a thermos's purpose is?
Yes.
If the water cools down immediately, would you have been successful? No, you would have not. All right. All right, we'll go ahead and stop there. Yes, go ahead and write this definition down. Conduction, when particles in the water are hot, they move in circles. And the kind of particles we're talking about are what? I have the definition up there. What is it?
Molecules?
It's water molecules. And what is it? What do we call that? What's the scientific definition for water? Yes, sir. H2O. Is that what you were going to say?
Yeah.
We'll continue with this tomorrow.